number of silver, it is 107. And the other isotope of silver so you have silver, atomic number is 57, and then atomic mass is 109. Of atomic masses, silver consists of the two isotopes, that ones and that ones, of what? Of atomic masses okay, so atomic masses 106.9. Gram. Atomic masses 106.9 gram a mole. And the one hundred 80.9 191. And the 108.91 gram per mole respectively. The relative abundance abundances of these isotopes are 51.88 for silver with atomic mass of 47 and the 107 and the second and 44.4. 48.12% for silver, for silver, for silver 47, $47,109. So the question asks you calculate the average atomic mass. But the question says that raise the relative atomic mass of silver element. So let us read the question clearly and then we are going to solve it. Silver consists of two isotopes. These are the two isotopes of silver. So you see that the air mass number is the same, 4747, and the atomic mass is not the same. So of atomic mass is 106.9 gram per mole, and then 180.91 gram per mole respectively. The relation or the relative abundances of these isotopes are 51.88% for silver isotope, and then 48.12% for silver element. We have to calculate the average atomic mass of what? Of silver. Can you try it? You can pause the video and then try that question, see if you get the right answer. Good, thank you for trying. Let us do correction in case that you missed it. Okay. So again, we say that that's all. That's the main focus that we should have in this topic. So solution, we say that we'll give you atomic masses, gram per mole, gram per mole. We'll be given here the percentage, their percentage intensities. Solution, so you have two silver isotopes as the question has stated, and then he said that the first step we say that data given. This is the data given below there. Then we go for the second step. Second step of solving this problem. You have to recall the new formula. We call the formula of finding relative atomic mass. So that's the first system. So the formula that I have to recall is the one that I've been repeating it several times. It's called the relative atomic mass. And this relative atomic mass, we say that is equal to the summation of product of what? Intensity times what? Depends. What are we given? Past. We'll be given relative boundness. Divided by sum of 40. Oh, sorry. Excuse me, please. I confused with this formula. This will be the product between the relative abundance, times intensity. Times isotopic what? Mass. Divided by what? Sum of 40 of relative abundance. Relative abundance. So you say that for that case, relative atomic mass, and then here we say that we have the product of relative abundance of the first peak times this mass to the charge ratio Okay. So here we say that we'll be given the relative atomic mass. We'll be given the relative atomic mass because the question states that silver consists of two isotopes, 1, 2, of atomic mass is this. So the relative atomic mass you are given. The relative atomic mass is 106.9. So we said that the relative atomic mass is equal to 106.9. So we introduce it in C position. This is equal to what? Silver consists of the two isotopes of that ones of atomic masses this and that ones respectively. the relative abundances of the isotopes are this value is 51.88% for the first isotopes, and then for this one, calculate the average atomic mass of 40 of silver. I'm sorry, we are not given the relative atomic mass. We are given something else. So when you say about data given, you have listed data givens, but you say that we are looking for the relative atomic mass. How many isotopes do you have? 2. So our formula will be mass Telly ratio 1 times relative abundance 1 plus mass isotope 2, then relative abundance 2 plus mass, or mass Telly ratio 3 times relative abundance of 3 divided by sum of relative abundance, which is 100. So we say that relative atomic mass, for this case, is equal to what? Mass of the first isotopes. So isotopic mass 160.39. So this is 160.9. We multiply with what? Which it is relative abundance, which is 51.88. 51.88, then we put close bracket because of the space. Then we say plus, again product of what? 108.29. 91 times 40 is abundance. And the abundance is 48.12. And then divided by 100. So relative atomic mass of silver, isotope of silver is, so just use your scientific calculator to do the computation there. And then, so 106.9 times 51.8 so plus 108.91 times 48.12. We divide this 100 and the response is 107.89 grams per mole. So this is 107.29 grams per mole. 0.87. Gram per mole. So we just say that according to this sentence, average atomic mass. So we say that the average atomic mass of this element, that is of silver isotope, is 107.87 grams per mole. So I think this is, you see that is how interesting these questions as long as we solve them. So the relative atomic mass for the second example is the one that I've written there. So let us go to the third example. Example 3. Concept. There is a certain concept here. Magnesium magnesium has 3 isotopes, stable isotopes. Has 3 stable isotopes. Isotopes of masses 29.985, 985, and 4 and 985 atomic mass unit. The relative abundances, and I'd like just to leave these questions as your homework. You have to try before we go for the lecture series. The relative abundance so the relative abundances of 3 isotopes, are 30.395, 30.9, abundances of 3 isotopes are 39.35, 5.0, 0.65, and 5.5, 85 respectively. Calculate average atomic mass. Calculate average atomic mass of that element. So use the concept that I have taught you to understand that the magnesium has 3 stable isotopes of masses 29.9 and then 29.985, 24.985 atomic mass unit. So these isotopes has real numbers, but I wrote 2. Excuse me, I want to make corrections for this question. which is 23. So let me do minor correction. So that you have accurate data. So masses is 23.98. Twenty-three point 985, 24.9, 24.985, and 25.98, 25.982. Atomic mass unit. The rough abundance are 39.355.065 and 5.585. Yeah, everything's correct. Make sure that you try. Make sure that you try to do this homework yourself and to ask help from anyone else. And then join me in the lecture series of mass spectrometer. I'd like to thank you for watching this video. Thank you for your time. One thing is, I believe you have enjoyed a lot. Make sure to watch some other videos in this channel called about advanced chemistry. So, and then make sure to watch some other videos for physics and the advanced mathematics and basic applied mathematics. So I think that the sessions was very interesting to you. I thank God who have helped me to teach you this concept. So I would like to ask you that to make sure to try that questions before we come for the third sessions, when we'll be solving problems or some other problems and even conceptual of the atomic structure. So I would like to thank you once again. See you in the next lecture.